All right, so this is how we're going to check our assignment for today. So I am on page 761, and we are going through problems 5 through 9. If you don't get the answers I get, make sure you are correcting them. So number 5 says find the number of possible routes from Eastland to Johnstown that pass through Harping. Then find the probability that State and Fairview will be used if a route is selected at random. State the probability as a fraction and percent. Well, first of all, we have to look at how many routes do you have from Eastland to Harping. And you can see that there is only 2. So we have 2 options to get from Eastland to Harping. Times, we have 3 routes from Harping to Johnstown. Therefore, we have 6 total routes. Okay? Now we have to find the probability that we will use the route State and Fairview. Well, there's only one option to use State, and there's only one option to use Fairview. Therefore, 1 times 1 is 1. And there's 1 out of 6 options to use State and Fairview. That as a decimal is 1700ths, which is the same as 17%. Yes, it's okay if you don't have the decimal because it just wanted the fraction and percent. Number 6, find the number of possible choices for a 2-digit number that is greater than 19. Then find the number of possible choices for a 4-digit personal identification number if the digits cannot be repeated. So on number 6, the first part is finding the number of possible choices for a 2-digit number that is greater than 19. The first thing you have to ask yourself, is 19 greater than 19? And no, it's not. Therefore, the first number we could use is 20. Then you have to think you could count all the way up from 20 to 99 because 100 will not work because it is 3 digits. Therefore, how many numbers are there from 20 to 99? There are 80. So that first answer should have been 80. Then, this is a totally different question. We have to find the number of possible choices for a 4-digit PIN number. And you cannot repeat the digits. So what that means is I have 4 digits. So this would be digit number 1, number 2, number 3, and number 4. If I use 0 for the first digit, I cannot use 0 for the second, third, or fourth. So now you have to think, well, how many single digits numbers are there? And there would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because you can't use 10 since it's a 2-digit number. Therefore, there are 10 total possible choices for that first PIN number. However, since we use one of the 10 options, we only have 9 options for the second digit. Then since we use one of the 9, we only have 8 for the third digit, and since we use one of the 8 options, we only have 7 for the fourth. Therefore, 10 times 9 times 8 times 7 is 5,040. So forget that. There are 5,040 total possible choices for a 4-digit PIN number. All right, number 7, an electronics company makes educational apps for 5 subjects, including math. The apps have 10 versions, with a different avatar in each version. One version has an avatar that looks similar to a lion. The company is randomly giving free apps to its customers. Find the probability of randomly receiving a math app with a lion avatar. How likely is the probability of receiving this app at random? So first of all, we have to think of, we have how many subjects that are choices, and how many different avatars are there? Well, we have 5 subjects times, there's 10 different versions, and each version has a different avatar. Therefore, there are 10 different avatars. So 5 times 10 is 50. So you would have 50 total outcomes. Now, we have to think about what's the probability of randomly receiving a math app with a lion avatar. Well, now we only have one subject, which is math, and we only have one avatar, which is a lion. Therefore, 1 times 1 is 1. And I have a 1 out of 50 chance of selecting a math app with a lion avatar. This as a decimal is 2/100, which is the same as 2%. Since 2% is less than 50, we would say it is unlikely that you would get that app. All right, the next page. Sorry about that. All right, the next page. So a sandwich shop offers 4 different meats and 2 different cheeses. Suppose the sandwich shop offers 24 meat cheese sandwiches. How many different breads does the sandwich shop use? Okay, so you have to think of your sandwich. We have meat choices, we have cheese choices, and we have bread choices. Okay? And it says that they have 24 different meat cheese sandwiches. Therefore, we're actually given the total outcomes because there are 24 options to choose from. Okay, it says that we have 4 different meats times 2 different cheeses, and we need to figure out how many breads there are. So we don't know this. So what I would think of is 4 times 2 is 8, and 8 times what gives me 24? 8 times 3 gives me 24. Therefore, there are 3 different bread choices. Number 9, a store offers 32 t-shirt designs and 11 choices of color. Is the store advertisement true? Explain. So if you look at the advertisement, it says a t-shirt for every day of the year. So we have to think, how many days are there in a year? We're going to say there's 365 days in a typical year. So we need to figure out if they have 32 designs and 11 colors, is there enough to wear a different shirt every single day? So this is going to be our designs. This is going to be our colors. If we have 32 designs times 11 colors, we would actually have 352 total outcomes, or total options to choose from. Therefore, our final answer is the store advertisement true? No, because if I only have 352 t-shirts to choose from, I don't have enough to wear a different one every day of the year. Therefore, my final answer would be no. The number of shirts equals 352, which is less than 360.